Hello, good afternoon, and thank you for joining us for this webinar on direct metal 3D printing. My name is Warner. I am part of a company called WB Engineering. We will be going over direct metal printing, some of the details of the technology, and also we will be breaking it down into some applications. Okay, so a little bit about WB Engineering. WB Engineering was established back in 2007. The business verticals we concentrate on are product development and design, specifically anything from a 2D napkin sketch all the way to products that are already being made in the hundreds of millions of units, of which we are going to then go ahead and optimize either because there's some rejects, because of quality control, or there's too much cost in terms of assembly, or manufacturability costs are a little bit high, or complexity, etc. So we can then optimize the designs. Also, we do prototyping, and we help our customers then manufacture their products as well, whether it be locally or abroad. Additionally to being a product development and design company, we also are partners with 3D Systems. In addition to that, we are partners with Autodesk. So Autodesk offers a full line of software ranging from AEC applications to manufacturing to automation applications and animation applications. We offer the software and the training for that software. Today we're going to be focusing on our product line of 3D printing, specifically direct metal 3D printing. A little bit of background on 3D Systems. So 3D Systems is actually the founder of the industry, period, right? So founder of the company, Chuck Hall, first commercialized SLA 3D printing back in 1988. 3D Systems was also the company who invented selective laser sintering, which is SLS, and first commercialized it in 1992. Also, 3D Systems invented color jet printing and commercialized it in 1994. I like to always put an asterisk on the end of this one. A company called Z Corp invented color jet printing, but Z Corp was then purchased by 3D Systems, hence now history books will say 3D Systems invented color printing. Moving forward, 3D Systems also invented a technology called multi-jet printing, or MJP, and commercialized it back in 1996. So therefore, 3D Systems is the inventor and innovator of a large percentage of the technologies that you currently see on the market in terms of 3D printing. So first poll question. I'm going to go ahead and ask to see if we can get some more information about our audience. First question would be, are you currently using 3D printing? And if so, are you using that in-house? Are you outsourcing it? Are you doing both? Or no, you're not using 3D printing at all? Give you guys a couple seconds, and we will then move on with the presentation. Okay, a couple more seconds till the final people fill it out. Okay, so I'm going to now close the polls, and we will be moving on to the rest of our presentation. So, specifically when talking about metal 3D printing, 3D Systems actually offers a variety of 3D printers. So the 3D printers range from our ProX 100 all the way up to our ProX 400, which I apologize, I should have taken the asterisks off of that. It is currently available. It's just an older slide, so I apologize. The benefits of doing direct metal printing we'll get into in more detail throughout the webinar. But in general, is complexity is free, right? So where machining and even casting, you have to take into consideration a significant amount of limitations due to the processes that you're using. With direct metal printing, all of that added complexity doesn't necessarily add a cost to your part. So therefore now you can actually start designing with function in mind as opposed to with the limitations of the tools you have to actually produce these parts in mind. So now we're going to get into a quick video of direct metal printing. Okay, so another quick poll question here before we get going. I want to see if we can learn a little bit more about our audience. So we want to actually see if this is something that you're joining us on this webinar just to do some research, or if you're actually on the market to purchase a 3D printer. Our 3D printers do require a significant amount of capital investment, and we know this does take a long time, a lot of research to get up to speed. So we just wanted to check in, see if this is something that needs immediate attention, or if you need us to help you better understand the application and the 3D printing capabilities before you make a decision on which one of the printers you can actually use. So I'll give you guys a couple more seconds to finish up, and then we'll be moving on to the rest of the presentation. Okay, thank you. So, why metal 3D printing? Well, you can actually produce fully functional metal parts in hours as opposed to having to wait days, even weeks for metal parts. So the biggest advantage here is not only do you have to not worry about waiting on lead times, you can now also take advantage of the fact that when you were using a CNC machine to do said task, and now you have a metal printer to do it, now you have essentially a vacant CNC machine that you can then or they can do another task. And then also you do have some increased build speeds with certain geometries, right? So as complexity increases with metal 3D printing, time doesn't necessarily increase, where with more traditional manufacturing, an additional undercut or additional access that might be required, it does require more setup, more tooling, etc. So therefore the ProX 400 actually allows you to turn around parts in a lot faster, more efficient manner in a lot of situations. So now you can also do large parts, right? So 3D printing is no longer limited to small volumes when it comes to metal. Now with the recent launch of our ProX 400 late last year, the availability of 500 by 500 by 500 millimeter build volume is available, and that build volume is extremely large for direct metal printing, especially when taking into consideration the precision and accuracy that these printers do offer in that build volume. So what's another application you can use direct metal 3D printing for? One is hard tooling molds. So you can produce hard tooling production with direct metal printing. You have more design freedom, so you don't have to worry about geometry limitations due to how many axes your CNC machine printer has, or how complex it is to do all the tooling, how to do all the fixtures, etc., how long the added undercut's going to take for your machinist to do, and maybe if it makes that impractical or not, etc. So you don't have to worry about those details. Also, faster than multi-step CNC, which is basically what I just stated. So to build with direct metal printing, in this image right here, you see there's 12 inserts. This essentially took about 50 hours to print on a Pro X 300. You have extremely smooth vertical walls, and you have undercuts without supports in these objects here. So you can produce these parts unattended in essentially a 48-hour period. The next thing is you can actually produce and use parts as well, right? So you don't necessarily just have to do tooling with these 3D printers. When you have extremely complex end-use parts that aren't mass-produced, and even in some cases, if they are mass-produced, you can actually print these directly from your metal 3D printer. So you can increase the flexibility of your design without having additional charges. You have no design limitations. I'll put an asterisk on the end of that because there are some limitations in terms of wall thickness, and then also let's be real, there's a limitation on build volume as well, right? So there is very little design limitations, put it that way. You can reduce part count and weight, so that's a very significant point there, where in some scenarios when you design something you have to think about how are you going to machine it, and then you might realize that you have to divide the part into multiple parts, which then require assembly, which also requires stock of different parts, tracking, new universal product code numbers, etc. So now when you can actually produce a more complex part out of one single part, you have less quality control, less stock you have to take into consideration, less failure points, less assembly costs, and then also you in that instance can now not worry about the certain complex detail and focus on the functionality, and therefore you might end up with a better product overall just because you're able to do what you want to do without taking into consideration limitations or complexity of how this is actually going to be produced and the feasibility of the part. The next thing is you have a large choice in standard metal alloys and ceramics, right? So directly from 3D Systems, you can get your printer with one of these 4 alloys. Now there are many other alloys and ceramics that you can actually feed into the printer. From 3D Systems, though, there's 4 that are readily available. I would recommend if you are getting one of these printers, you work with one of these right off the bat and then move forward. That said, though, we did just sell a printer to a customer which included titanium as the material which it was shipped with. So there are different metals that you can actually work with. These applications, obviously, the metals range, right? So cobalt chrome is a biocompatible metal. You can use that to actually implant. There are aluminum alloys. There are stainless steels and other forms of steels that can be used for different applications. So, like we mentioned before, you have unmatched design and manufacturing freedom. So the image on the left is something you already saw, which is a part that used to be made out of multiple parts, which was then redesigned as one part to be 3D printed. The one on the right just shows an artistic 3D file which was 3D printed to show just the complexity that this can actually produce without the requirement of secondary processes like casting and things like that. So you can get something like this in metal directly off of your printer. So the density of the parts, and I'm sorry it doesn't show up on the screen. Maybe here we go. Sorry, I just animated it. So the density of the parts are actually 99 or greater than 99% dense, right? So actually I've heard figures of 99.9% dense. What does that mean? Well, it's actually more stable than a cast part, which in general tends to be about 98% dense. What does that also mean? You can actually get a polished finish off of these. So if you actually take the time to then polish the surface on the exterior, now you can get polished parts with very complex geometry right off of your 3D printer. Also, 3D Systems direct metal printers, they offer the highest accuracy and best detail resolution currently on the market. So you can do wall thicknesses that are extremely, extremely thin, but in this scenario we have 150 micron wall thickness, and then also the image on the right just kind of shows very, very fine details that are self-standing that can be produced on these. With the ProX direct metal printer, you work with the lowest particle size. So we're talking about particle sizes that range between 5 and 30 microns. It gives you excellent material quality, excellent surface finish. Additionally, you have the surface finish in terms of RA. You have cobalt chrome at 6 micron. You have titanium that ranges from 8 to 10 microns. You have limited mechanical stress with the parts that are being produced. You have increased definition with details, features, and microns that can go down to about 150 microns. And also you have a reduction of size of production supports that are easy to remove and leave minimal scarring on the parts, right? So one thing I like to point out is that unlike SLS systems, direct metal printing systems actually do require some support scaffolds. Now the support scaffolds, you think metal support scaffolds, while it's going to be near impossible to reduce, you can actually remove them by hand. That's how delicate they are. That said though, if you do have a face that is touching the support structure, you might want to do some secondary machining or orient your part strategically so that that side does not require extremely smooth finishes. Let's get into another poll question here. So now we want to know, what would you actually like to use 3D printing for? So are you going to be using 3D printing for prototypes, end-use products, for casting, tooling, or another application that we might not be aware of currently? It's always interesting to see how our customers are using 3D printers, because even though we are exposed to 3D printing, and we have been exposed to 3D printing for a long time, I think that tends to kind of narrow down your visibility as to the possibilities sometimes. Just because you're really close to the technology for such a long time, you tend to not think outside of the box like you would when somebody's newly introduced to this technology. So I'll go ahead and close this one up. Looks like everybody answered. So now I'm going to go on. So we spoke about big parts, right? So now we can actually do extremely small parts as well. So in this image you actually see a very, very small gear that actually has 20 teeth on it. It's 2 millimeters in diameter. Additionally, we have a C-clamp holder holding with 16 through wire, right? So this is something that is extremely small with very high precision. So your applications can vary from very small, complex parts to actually relatively large parts as well. You can also get extremely high repeatability between these, right? So you have excellent tolerances and repeatability to the point of 20 microns in all 3 axes within the build, and also from build to build, right? So it's important when you're going to be using this to develop one part many times over that you do have a reliability when you go from one print to the next print to the next print. So it's important that that the printers not only are accurate within one print, but they are also accurate from print to print. Next thing is, let's look at some applications, right? So automotive is one of the big applications. Currently, the biggest one is competitive racing, right? So automotive industries, not necessarily commercially driven cars aren't taking advantage of this technology quite yet, because 3D printing is, in general, a more costly methodology to produce something if you're going to mass production as opposed to the traditional routes. But let's say you are trying to get the most bang for your design, and this is something that just requires 1, 2, maybe 100 applications. 3D printing actually can come into the scenario and produce very high performance parts, so that you can implement these into automotive racing applications, or even just a prototype before you go to commercial manufacturing with something that's going to be required hundreds of thousands of times. Here's a quick video on how metal printing is being implemented on the track.
I'm an avid motorsports enthusiast, and during the course of events that I've been able to participate in, I came across English Racing, and they shared a challenge they were having with me regarding some of their half-mile racing. And when I listened to the issue that they had, and that was related to high oil pressure at excessively high RPMs, additive manufacturing came to mind as an immediate solution.
The guy that I was working with actually came up with the original idea of underdriving the oil pump. We decided to go to manufacturing after we had oiling problems with this car at a previous event. It turned out that it was really the perfect candidate for 3D metal printing because it's a pretty complicated part to make, and the tolerances have to be very tight.
The Part 300 came to mind immediately for the English Racing job because of the geometry of the parts. They would be very difficult to machine using standard machining on a mill or a lathe.
So the ProX 300 allows us to do a lot that we can't do in typical machining technologies. So by having the ability to take a part from 3D design to a full functional metal prototype and then give that to our customer to let them test it on their equipment. So take a solid model from the computer, put that into the machine. You have an hour or two of setup, and then you walk away and come back at the end of the day and the part's done.
Anything gear is really difficult to make on a lathe or a 5-axis CNC, and so cost-effective wise at our quantity, it worked out really well. Part quality actually turned out better than I expected. After the vibratory, the part's really smooth, so the timing belt wear and stuff is great on the part.
The ability to go to the full-on production phase is something unique to the machine. So by using the ProX 300, we're able to not only reduce the time to development, but also the cost to produce that initial part.
So this car was seeing a good 109 to 115 psi of oil pressure at higher RPM, and we're down now to about 95 or 96 pounds. And then it also didn't compromise the idle oil pressure either. So we went from 30-some psi down to only 22 or 24. There's no doubt to me that this oil pump gear is like the ultimate solution in the stock oil system.
Without the ProX 300, it would have taken at least 10 times as long to produce the initial prototype part. The ProX 300 is an important and transformative tool for our company. It allows us to provide solutions for our customers that we could never provide before, and it allows us to do it faster than we've ever been able to do it in the past.
Okay, so after seeing that, we want to learn a little bit more about our audience here. So, for those of you who actually are currently on the market for a 3D printer or about to be on the market for a 3D printer, what is your current budget looking like? Okay, almost everybody voted. Going pretty quick. All right, that's about it. Thank you very much. I appreciate it. So next is our infamous part here, right? So this is an aerospace jet engine fuel nozzle. So This was used to develop a part for a large aerospace company. You guys might have heard of it, GE. They actually produce this part, and they produce over 100,000 different products. They actually wanted to increase part optimization. What they did was they reduced the weight and also increased fuel saving via using direct metal printing. So not only does it help with the facilitation of actually creating geometry, the geometry that you can create can also create product improvements, i.e. in this scenario, weight reduction and actually fuel savings on the jet engine that they implemented this on. This next example of aerospace, this is extreme mass complexity, right? So in this scenario, this is a combustion chamber for a satellite. You go from the image on the left all the way to the image on the right. You notice there's a significant more amount of surface finish on, or surface area, I'm sorry, in the image on the right. This is actually low density mesh, and it's very, very fast to 3D print on a metal printer, impossible to do otherwise. It actually simplified the assembly of the part, and then also obviously helped with the cooling or the heat transfer properties of the product itself. Not to mention it reduced weight, and it is all one part, so it's a very very wide range of improvements just simply by going from traditional route to a very lightweight mesh directly off of a metal 3D printer with no added cost in terms of complexity. Next one is energy applications. You can actually do things like micro turbines. In this scenario, this was a micro turbine manufactured for Cermet Power. I'm sorry, from Cermet. You can also use direct metal 3D printing for dental applications. So in dental laboratories, cycle time is reduced from 4 days down to 2 days. Also, you eliminate multiple steps. Not to mention the cost of building each partial. These are actually called partial bridges in the image here. Each partial dropped from $85 down to $35 per unit. Why? Because not necessarily the material cost, it's actually the labor cost that's required to create these traditional, via the traditional method. Now it's fully automated. Next thing is jewelry, right? So you can actually manufacture jewelry directly off of these machines. So you can, if you're a jewelry or a watch manufacturer, you can get these directly off of machine. To be honest, I haven't seen these sold into the jewelry industry much. Reason being is that the majority of the clientele that we've seen in the jewelry industry tends to like precious metals, which currently the Pro X line of 3D printers does not accommodate precious metals. But we have seen this happen more so in the watch industry, not so much that requires precious metals, but they do like complex geometry. So that said, yes, jewelry is a good match for this, but we do have other 3D printers which cater more specifically to jewelry, like the ProJet CPX line, which is printing directly in wax, which you can cast in a precious metal like platinum or gold or silver, what have you. The next one, which I think is huge, is tooling, right? So with this tooling scenario, you can make extremely complex tooling. And this one is a blow mold for conforming molds. This example, the efficiency was increased by 30%. There was only a 60-hour build time for the full plate, and it's $130 for the parts in steel. The tooling applications, you can do direct integration of conformal cooling channels into the molds, which I'll get into in the next couple slides. You can repair damaged tool inserts, so therefore you don't have to actually remachine it. You can just 3D print out the tool inserts. You can also do, for die casting, direct integration of the tempering channels in near contour conditions for optimizing for heat diffusion. Next is specialized tooling. This is just kind of reiterating. This one was 12 inserts, roughly 50 hours, but we have estimates from 50 to 60 on our DMP 300. Very smooth vertical walls, and this does have unsupported undercuts. So this is a repeat slide from earlier that I just wanted to show as our specialized tooling. This is actually based off of a case study. So now conformal cooling is something that is very important, right? So it's been a long challenge to get even cooling inside of molds. In this scenario, complex cooling channels were created inside a software which 3D Systems also offers in order to reduce cycle time by 14% and also reduce overall cost by 16%. Also, not to mention, the part quality increased significantly as well because of the uniform cooling. So in the example for the for this, you'll see on the right, you'll see the SLA 3D printed part, so you can actually see the conformal cooling channels that are actually inside the direct metal 3D printed part. So that's just kind of giving you a little bit of insight, or not kind of giving you, it's giving you an internal view as to what the conformal cooling looks like inside of this tool versus the actual part on the right there. Another one is quartz bulb burners with integrated cooling, right? So this is just kind of reiterating that you can actually put some very complex geometry on the inside of this. In this scenario, they actually integrated 8 parts into one, so there's no longer any assembly issues here. Additionally, they have integrated cooling channels, which in turn improved performance lifetime of the actual part. So there's a long list of improvements just basically by being able to accomplish slightly more complex geometry. That way you don't have to actually assemble, and it actually improves performance. Next is patient-specific implants and devices. So this kind of brings home for me quite a bit. I graduated as a biomedical engineer. We do medical devices here at WB Engineering, but I'm always really enthusiastic about what 3D printing can do for the medical industry. When I was invited one time to actually see an orthopedic surgery of a knee replacement, and to my surprise, it was extremely what I would say archaic process, seemingly from an outside looking in, where it was cutting tools, the surgeon had a mask on, bone fragments, blood going everywhere. It was really something out of a horror movie. And to oversimplify the scenario, it's basically what they're trying to do is prepare the knee for a small, medium, or large implant, essentially. Nowadays, what you can do is you can get MRI or CT data from the patient itself, use that to design a full custom implant, and then also put this mesh finish on the outside to promote ingrowth. That way the product not only can be surgically implanted faster, more efficiently, and with less trauma, also the ingrowth pattern significantly helps for the absorption or intake of the part by the body itself. So medical applications are huge for metal 3D printing. So the build software, won't talk about this too much. Essentially, it's extremely easy. If you can submit something to a printer and you know how to put it in landscape or portrait, it's basically as far as you're going to need to go. Now, that said, you do have the ability to optimize build parameters, optimize supports, and really start tweaking the details of your print. But long story short is you can basically set it and forget it, and it'll 3D print your part. Once you actually get used to your system and used to the geometry, you can actually start fine-tuning the build parameters and supports to that get a little bit more juice out of your 3D printer. So that's one last question here. We're almost at the end of our webinar. So moving on, let's go on to do you want a sales rep to actually contact you, right? So I know a lot of you guys are here, and ladies are here for background information. You don't want to be bothered by us to to talk to you about seeing if you're going to be purchasing a 3D printer or not. But keep in mind, we offer 3D printing products, the printers themselves, and we also offer 3D printing as a service as well. So therefore, you don't necessarily have to be on the market to purchase a 3D printer. If you just want some general information about our services as well, we can help you out. But yeah, long story short is, if you need us to help you with purchasing a 3D printer, we can help you. If not, we can also help you with the services if it doesn't look like something that you're going to be bringing in-house. Thank you very much. I'm going to move on to the next one. So let's go over the overview of our products here. So now this is just kind of the overview of our metal printers, starting from our ProX 100, which is essentially our smallest unit. It's 4x4x3 roughly build volume. Then you go up to all the way to our ProX 500, which is almost a 20x20x20 build volume. So we have small metal 3D printers for those small complex applications, and then we also have our larger 3D printers, which are going to allow for either manufacturing of small units in large volume, or just the ability to create large, very precise, complex metal patterns. Okay, so why would you get into metal 3D printing, right? Well, one is you want to reduce time and cost for manufacturing of complex metal parts, right? So whether it be the fact that you just want to be able to produce prototypes without having to go through a third party to machine them, and the lead time is multiple weeks or months, you can actually do that in-house with very little effort and very little manpower. Also, you gain flexibility in terms of cycle time and part complexity. So therefore, as you add complexity, it's not going to necessarily increase print time. In some cases, you might even reduce print time because maybe you made it more skeletonized version. It's a more lightweight, more efficient version of what you started out with. Also, you have the benefit of a large choice of materials, right? So 4 very easily, readily available materials, but then also there's 18 or so that are available that I know of right off the bat, and there are some third-party materials that can also help you out with that. The next thing is you have fine resolution and the highest precision in terms of metal printing with 3D Systems metal printers, and then you have high repeatability between print to print, which is really nice for manufacturing applications, specifically for small complex parts that you can just pump out a bunch on these from one of our larger units. So that's the end of our presentation. I just want to, reiterate, thank you very much for spending the time with us. If you do have any questions, please submit them. I'd be more than happy to answer them. Additionally, just to summarize what we do, again, we do product development and design. We are able to leverage 3D printing in order to give us upper hand on the competition, and I think this is also something that our customers will benefit from as well. So if you don't necessarily think that 3D printing is something that's very, very beneficial, I urge you to do some research on your market, who's using 3D printing in your market, and I'm almost certain you'll see some examples of how people are being able to exploit this kind of technology in order to reduce cycle times, improve quality, and also innovate on their products a lot faster. With our customers, we tend to get to market faster and with less issues once we get to manufacturing, because we have access to 3D printing and we can prototype and test early and often with very little added cost and effort. So thank you very much for attending our webinar. I really appreciate your time. Everybody have a great weekend. If you need to forward this over to a colleague, we do have this available on wb-3d.com/webinars. You will have access to this via our website if you want to see it again, and also again feel free to contact us at sales@wb-3d.com or give us a call at 305-756-4401. Thank you everybody, appreciate it, and enjoy your weekend.